Quantum computing has always been full of promise, but also full of challenges. Stability, scalability, and reliability have held back this revolutionary technology. But Microsoft just made a breakthrough that could change everything. Their new quantum chip, built on topological qubits, may finally bring the field closer to practical, large-scale quantum computers. What does this mean for the future of computing? Let's get into it. Quantum computers have been in development for years, with researchers pushing the limits of technology to create machines that can solve complex problems beyond the reach of classical computers. Unlike conventional systems that process information using bits, either a 0 or a 1, quantum computers use qubits, which can exist in multiple states simultaneously. This ability, called superposition, allows quantum machines to perform calculations at speeds unattainable by even the most powerful supercomputers today. But quantum computing has a serious issue. Qubits are extremely fragile. They are highly susceptible to errors caused by noise, environmental interference, and instability. Even the best quantum systems require large numbers of extra qubits just for error correction, which makes building useful quantum computers incredibly difficult. While companies like Google and IBM have pursued superconducting qubits, Microsoft has taken a different approach. Instead of following the same path as its competitors, Microsoft has been working on a unique solution: topological qubits. The idea of topological quantum computing has intrigued physicists for decades because it promises qubits that are inherently more stable. Instead of relying on fragile physical particles, topological qubits are based on a special type of quasi-particle called Majorana zero modes. These quasi-particles aren't actual particles in the traditional sense, but rather mathematical constructs that behave in ways that could make them immune to common quantum errors. If successfully implemented, these qubits could drastically reduce the number of extra qubits needed for error correction, making large-scale quantum computing much more feasible. Microsoft's pursuit of this technology hasn't been easy. The company has spent nearly 20 years trying to build topological qubits, facing setbacks and scientific skepticism along the way. In 2018, a major research paper on Microsoft's approach had to be retracted due to errors, casting doubt on whether this method could work. But Microsoft didn't give up. Instead, it brought the research effort entirely in-house, refining the technology and addressing past mistakes. Now, after years of development, the company claims to be on the verge of a major breakthrough. This week, Microsoft announced that it has successfully created a prototype quantum chip containing 8 topological qubits. This is a crucial milestone because it demonstrates that these qubits can be physically constructed and function as expected. The company also shared findings in the prestigious journal Nature, where researchers detailed how they successfully read out the quantum states of these qubits. Essentially, they proved that their qubits can hold and process quantum information in a stable way, something that has been incredibly difficult with other approaches. One of the biggest challenges in quantum computing is maintaining quantum states for long enough to perform meaningful calculations. Superconducting qubits, the type used by companies like Google and IBM, require extremely complex error correction mechanisms to function at scale. Microsoft's approach could eliminate much of this overhead by using the unique properties of topological qubits. Theoretically, these qubits could retain their quantum states far more reliably, making error correction simpler and quantum operations more efficient. To understand why this is so significant, let's take a look at how Microsoft's topological qubits work. They rely on Majorana quasi-particles, which were first proposed nearly 90 years ago. Majorana fermions are unique because they are their own antiparticles. When two of them meet, they annihilate each other. Microsoft's researchers are attempting to create these quasi-particles inside special nanowires made from indium arsenide. These wires are placed next to superconducting aluminum, which allows quantum states to be manipulated in a controlled way. Under the right conditions, electrons in these nanowires split into 2 separate halves, effectively hiding themselves at opposite ends of the wire. These halves act as Majorana zero modes, which can be braided around each other in specific ways to encode quantum information. The key advantage here is that these topological states are far more resistant to interference than standard qubits. In theory, They should be able to hold quantum information much longer without error, making them ideal building blocks for large-scale quantum systems. The recent paper published by Microsoft's team showed that they were able to measure the presence of these Majorana states with high accuracy. Essentially, they confirmed that their quantum system can reliably distinguish between different quantum states, something that is essential for quantum computation. While this does not yet prove that Microsoft has a fully functional topological quantum computer, it is a significant step forward. Experts in the field have reacted with cautious optimism. Many acknowledge that this could be a major breakthrough if Microsoft's claims hold up under further scrutiny. Some researchers, like Scott Aronson of the University of Texas at Austin, believe that this approach has the potential to revolutionize quantum computing. Others remain skeptical, pointing out that similar claims in the past have not always been verified by independent experiments. One challenge Microsoft still faces is scaling up its technology. While creating 8 qubits is impressive, modern quantum computers need thousands or even millions of qubits to reach their full potential. The company has outlined an ambitious roadmap to build a fault-tolerant quantum computer with thousands of qubits in just a few years. Beyond that, they have a long-term goal of creating chips containing up to 1 million qubits, enough to unlock truly groundbreaking quantum applications. The competition in quantum computing is fierce. Google made headlines in 2019 by claiming to have achieved quantum supremacy, a milestone where a quantum computer outperforms the best classical supercomputers. IBM, meanwhile, has been rapidly increasing the number of qubits in its superconducting quantum processors. Startups like PsiQuantum are exploring other approaches, such as photonic quantum computing, which uses light instead of electrons to perform quantum calculations. Microsoft's bet on topological qubits is unique because, if successful, it could allow quantum computers to scale up more efficiently than other methods. Instead of requiring thousands of additional qubits for error correction, Microsoft's machines could use significantly fewer resources to achieve the same level of computational power. This could give them an edge in the race to build the first truly useful quantum computer. One factor that could help Microsoft catch up is support from the US government. The Defense Advanced Research Projects Agency recently selected Microsoft as one of 2 companies to receive funding for developing large-scale quantum computing systems. The other company, PsiQuantum, is focused on photonic qubits, meaning that the government is interested in multiple different quantum approaches. This investment could accelerate Microsoft's progress and help it close the gap with competitors who have taken different paths. While there is still a long way to go, the implications of Microsoft's research are enormous. If they succeed, quantum computers could revolutionize industries ranging from cryptography and materials science to drug discovery and artificial intelligence. These machines could solve problems that are currently impossible for classical computers, unlocking new levels of computational power that could reshape the world. But before that happens, Microsoft still has many hurdles to overcome. The company needs to prove that its topological qubits can be reliably scaled up. It also needs to demonstrate that these qubits can perform real quantum operations beyond theoretical calculations. Until then, researchers will continue to scrutinize their work, testing whether this new approach truly lives up to its promise. Despite the challenges, Microsoft's latest achievement is a sign that quantum computing is advancing faster than ever. Whether or not topological qubits become the dominant technology, this progress moves the entire field forward. And as scientists and engineers continue pushing the boundaries of what's possible, one thing is clear: the future of computing is being rewritten, one qubit at a time. Quantum computing is evolving, and Microsoft's breakthrough could be a game changer. Their topological qubits offer a new path to stability and scalability, but there's still a long road ahead. If this technology succeeds, it could reshape industries and unlock new frontiers in computation. Like, subscribe, and let us know. Do you think Microsoft will lead the quantum revolution? See you in the next one.